students.
Good morning.
Can you hear me properly? Because yesterday I saw video later, it was not audible. Okay. Shall we start the new chapter, quadrilateral? Or in the previous chapter, any doubts are there?
No, sir.
No. We shall start the new chapter, quadrilateral. Chapter number 7. While writing the notes, you are not writing chapter number and then title of the chapter. Some of you. Quadrilateral. Quadrilateral. Can anyone tell me what is quadrilateral? What is quadrilateral? What is quadrilateral? Quadrilateral is a four-sided closed figure. It is just a four-sided closed figure. Four-sided closed figure is called as a quadrilateral. Okay. Or we can say it is a four-sided polygon. Polygon is four sides. The quadrilateral. First point, what is polygon? Polygon is a closed figure. It is a made up of straight lines and it is a closed figure. A closed figure made up of straight lines is a polygon. Okay. Circle is not polygon because circle has no straight line. For example, triangle is a polygon. Then four-sided closed figure is a quadrilateral. This is also polygon. Okay. Or pentagon is a polygon. Hexagon is also polygon. What is polygon? Polygon is a closed figure. Okay, which has only straight lines, or the figure formed by straight line and which is closed. It's a polygon. Polygon is the minimum number of sides is triangle. Because with only two sides, you cannot make closed figure. The polygon is minimum size is triangle. It is a three-sided closed figure. Or triangle is a three-sided polygon. It is quadrilateral is a four-sided polygon. Or we can say quadrilateral is a four-sided closed figure. Okay? Quadrilateral is a four-sided closed figure. Pentagon, depending upon the number of sides, polygons have different names. That we have already studied the pentagon, hexagon, all that. In this chapter, we are going to study quadrilateral. What is quadrilateral now? Quadrilateral is a four-sided closed figure. It is a four-sided closed figure. Now, in square, there are four sides and it is closed. So, square is also quadrilateral. Rectangle. Rectangle is a four-sided closed figure. So, it is also quadrilateral. Rhombus, kite, these are all quadrilateral. These are all four-sided closed figures. Therefore, these are all quadrilateral. There are two kinds of polygons, or there are two kinds of quadrilateral. One is a convex quadrilateral, another is concave quadrilateral. Here, like a convex and concave mirrors. Here, we say convex quadrilateral. Another one, concave quadrilateral. Concave quadrilateral. Okay. For convex quadrilateral, I'll draw one diagram and explain it. So it is a four-sided closed figure A, B, C. B is a quadrilateral. Another one I will draw four-sided. This also has four sides A, B, C, and D. D is here. This is also four-sided. This is also four-sided. Both are quadrilateral. For this we call this as a convex quadrilateral. This as concave quadrilateral. How to define convex and concave quadrilateral? So to define whether it is convex or concave, to check that we should draw the diagonal. Now I will draw the diagonal. There are two diagonals here. Diagonal is a line connecting opposite vertices, or the diagonal is a line segment connecting non-consecutive vertices. Non-consecutive. Here A and B are consecutive. A and B are consecutive. Which are consecutive vertices? The two vertices in which one line is common, or one line segment or side is common, are the consecutive vertices. A and B are consecutive because AB is common for both. B and C, these are consecutive vertices. Okay, because BC is common for both. C and D are consecutive vertices because CD is common for both. Similarly, A and D are consecutive because line segment AD is common. Whereas you take A and C, you take A and C. These are not consecutive. These are non-consecutive vertices. These are non-consecutive vertices. These have not common side. Here A is with side AB and AD, and C is on the side CD and BC. So A and C have not any common side. So those are non-consecutive. Non-consecutive. Okay, one more example I'll explain here, then you will understand. For example, if I have one pentagon, okay, A, B, C, D, E, F. This is not quadrilateral. I am explaining the diagonal. I am explaining consecutive and non-consecutive vertices. For that, I have taken this. Here, A and B are consecutive because AB is common. B and C are consecutive. C and D are consecutive because CD is common. B and D are consecutive. E and F are consecutive vertices. So, which are non-consecutive? Here, take A and C. A and C. So, join the line. A and C are non-consecutive vertices. The line which joins non-consecutive vertices is a diagonal. This is also diagonal here. Diagonal need not make exactly two equal parts. This is also diagonal. And A and B are non-consecutive. Join this. This is also diagonal. A and B are non-consecutive. Join. This is also diagonal. Okay. A and F you cannot draw. From B also, B and F, B and E, B and E. Okay, like this you can draw different diagonals. My point is here. I explain you what we mean by consecutive and non-consecutive vertices. Okay. Now, in this one, which is convex and which is concave quadrilateral, we shall see. Here, draw the two diagonals. There are two diagonals. Okay. See in this diagram, AC is one diagonal, BD is another diagonal. Both the diagonals are within the quadrilateral. Within means they are in the interior of the quadrilateral. Interior means inside. Exterior means outside. Okay. For example, you might have heard interior designer. Interior designer means who designs house inside. Interior means inside, exterior means outside. Boundary of this quadrilateral A, B, C, D, E, A, B, B, C, C, D, D, A. These lines are also in the interior. Okay? That is, the boundary is also in the interior of the quadrilateral. Interior means I told inside. Then exterior means outside. Then where is the boundary? Boundary is inside or outside? X boundary is also inside. It is in the interior. Like you are having the house. For house you will be having compound wall. Inside the compound wall it is interior. Outside the compound wall it is exterior. But what about compound? Compound is yours or others? That is also yours. Means compound is also in the interior. Like that. Here, interior is the inner region or region enclosed by the quadrilateral. Region enclosed by the quadrilateral. Here, boundary also is included in the interior region. Here, what I said, diagonal AC and BD lie within the diagonal, within the quadrilateral. Diagonals AC and BD lie within or lie in the interior of the quadrilateral. If all the diagonals lie, if all the diagonals completely lie in the interior of the quadrilateral, then that quadrilateral is convex quadrilateral. Which is convex quadrilateral? If the diagonals lie completely in the interior of the quadrilateral. Here AC and BD, are these outside? Those are inside only. So it is convex quadrilateral. Now see this. Here AB is one side, BC another, CD, AD. It is a four-sided closed figure. This is also quadrilateral. This is also quadrilateral. So what is the diagonal? I said diagonal is a line segment that joins non-consecutive products. A and B are consecutive. Okay. A and B are consecutive. C and D are consecutive. Whereas B and D non-consecutive join. This is one diagonal. Okay. Another one, A and C. D I'll write it. A and C non-consecutive products join. That is another diagonal. Here the diagonal, two diagonals are there. One is BD, another one is AC. See the diagonal AC. AC is not within the quadrilateral. It is outside. The diagonal AC is not within the quadrilateral. It is the diagonal AC is in the exterior of the quadrilateral. So such quadrilaterals are called concave quadrilateral. It is a concave. Understanding? It is a concave quadrilateral. Or other way is, one more way is, at least one of the angle will be obtuse angle, interior angle. See this angle. This is obtuse. Okay. Now you have understood convex and concave quadrilateral. Here in this chapter, we are going to study convex quadrilateral. Convex quadrilateral. not a concave quadrilateral. Understood? Okay. We have already studied sum of angles of a triangle is 180 degrees. Okay, that is called angle sum property of a triangle. I will remind you what is angle sum property of triangle first. Angle sum property of a triangle. What is angle sum property of a triangle? Sum of angles of any triangle is 180 degrees. Sum of angles of any triangle is 180 degrees. Okay. Sum of angles of any triangle is 180 degrees. This already you have studied that. Just to remind you, I am writing. So if I draw one triangle. A, B, C. So, what angle sum property of triangle tells? Angle A plus angle B plus angle C is 180 degrees. This is called angle sum property of a triangle. Similarly, angle sum property of quadrilateral. What is the sum of the angles of a quadrilateral? So we shall write. Angle sum property of quadrilateral. Angle sum property of quadrilateral. Angle sum property of quadrilateral. Sum of angles means interior always. Sum of angles of any quadrilateral is 360 degrees. Sum of angles of triangle is 180 degrees. Whereas sum of angles of any quadrilateral is 360 degrees. We can disturbance is someone is speaking. A, B, C, D. In quadrilateral A, B, C, D. Angle A plus angle B plus angle C plus angle D. It is 360 degrees. You take any quadrilateral. You take square, you take a rectangle or parallelogram, rhombus. In all quadrilaterals, sum of angles of any quadrilateral. We have to use the word any quadrilateral. Means it can be rhombus, square, rectangle, height, whatever. Sum of all angles will be 360 degrees. Okay, it's very easy to prove this. Just you draw a diagonal. Okay, then here sum of angles of this triangle is 180. Sum of angles of this triangle is 180. 180 plus 180 becomes 360. Because we can form true triangles in quadrilateral. We know sum of angles of one triangle is 180 degrees. So this is 180 degrees. Its sum is 180. So 180 plus 180, 360. Okay. Systematic steps we can write. So how to write in quadrilateral in quadrilateral A B C D diagonal BD divide it into two triangles. Which are those two triangles? Triangle ABD and BCD. Triangle BCD. Okay. In triangle ABD, say angle BAD plus angle ADB. BAD is this angle, this one. ADB, angle ADB plus this angle ABD, angle ABD equal to sum of angles of a triangle is how much? 180 degrees. So this is 1. Then another triangle is there, BCD. In triangle BCD, this triangle BCD angle BCD plus this angle I took CD or BCD BDC, angle BDC, this one. Then angle CBD, this is also 180 degrees. Call this as number 2. Just I have marked to make you understand. These are not equal. Okay. Now, in quadrilateral ABCD, angle ABC, this one, angle ABC plus BCD, this one, angle BCD. These are all not equal. You can put mark like different marks. Then plus angle CDA, this one, CDA, plus angle BAB, equal to, equal to. ABC, where is ABC? Here is ABC. ABC is ABD plus DBC. I'll split this here. ABC is angle ABD, ABD, ABC is nothing but ABD plus DBC. Angle DBC. This one, this equal to this much I have written. Plus angle BCD already is angle BCD plus CDA. CDA is CDB plus ADB. So this is CDA. CDA equal to angle CDB plus angle ADD. ADB plus BAD, angle BAD. Now, if you arrange these angles, here BAD, here is BAD, here is BAD, here BAD. Then ADB, here is ADB. Then ABD, where is ABD? These angles 1, 2, 3 are here. 1, 2, 3. Then this one, second equation. BCD, where is the BCD? Here BCD. Here. BDC. Okay, where is BDC? Here BDC. Here BDC. Then CBD. CBD here. Yeah. Okay. So it is BAD plus ADB plus ABD is 180. So 180, this is 180. 180 plus 180 becomes 360. Or if you want one more step, I'll write. If you arrange these angles, it becomes angle ABD plus angle ADB plus angle BAB plus angle DBC plus angle BCD plus angle CDB. This is equal to sum of, these are the sum of angles of a triangle, and these are also sum of angles of another triangle. So this is 180 degrees, that is also 180 degrees, 180 plus 180, 360 degrees. Okay, this is how we can prove sum of angles of any quadrilateral is 360 degrees. You understood, students? Have you understood?
Yes.
Yes, sir.
Okay, then next, types of quadrilateral. Types of quadrilateral. Types of quadrilateral. A, B, C, D. Okay, is it quadrilateral? Students, this is also quadrilateral, isn't it? Because it is having four sides. Therefore, it is a quadrilateral. Four-sided closed figure is called a quadrilateral. What is the name of this quadrilateral? Can you tell me? Is it rectangle or square or rhombus or it is rectangular? What is its name?
Rectangle.
It is rectangle. Okay. What is rectangle? Can you tell me? Okay. Can you approximately tell me whether angle B is 90 degree or angle C is 90 degree?
C.
C is 90 degree? Okay, then I'll draw. I think you are not getting.
Parallelogram.
Is it rectangle? Is
No,
it
sir.
rectangle? Is it quadrilateral or rectangle or parallelogram? What is name of this? Have you not seen this?
Parallelogram.
Parallelogram. Okay. Someone told quadrilateral. In quadrilateral, all angles are 90 degrees. There is no much difference between quadrilateral and parallelogram. In quadrilateral, all angles are this one. In rectangle, all angles are 90 degrees. Here, by just observation, we can say these angles C, D, A, B are not 90 degrees. It is a parallelogram. Correct? What is parallelogram? Can you tell me? Parallelogram. What is the definition? For which kind of figure you call it as a parallelogram? For which kind of figure you are going to call it as a parallelogram? Tell me. It is a parallelogram. Okay. What is its definition? Parallelogram is a quadrilateral. Correct? It is a quadrilateral. First point is it is a quadrilateral in which opposite sides are parallel. In which opposite sides are parallel. So its definition is quadrilateral is a parallelogram in which its opposite sides are parallel. Which are opposite sides? AD and BC. These two are parallel. Or this is parallel symbol. Okay, if you write like this, it is equal symbol. If I write like this, if I draw like this, AD equals BC. Okay. Now I have drawn this symbol. Means what? AD is parallel to BC. Next here also I'll mark. AD is parallel to C. AD and BC are opposite sides. These are parallel. AD and CD are opposite sides. These are parallel. Okay. What do you mean by parallel lines? Can you tell me? The lines which never meet. For example, if AD and CD are there, no. If produce CD and AD also, they never meet. For example, in your home, two rods of a window are parallel. Correct? Two opposite edges of a table, those are parallel, they never meet. Here, AD is parallel to BC, AB is parallel to CD. A quadrilateral in which opposite sides are parallel is known as a parallelogram. And opposite sides will be equal also. That is next property. Okay. What is parallelogram? Parallelogram is a quadrilateral in which opposite sides are parallel is a parallelogram. Remaining square, rhombus, rectangle, those can be defined in terms of parallelogram. What is square? Can you tell me? What is a square? What is square? Square is also parallelogram. It is a special parallelogram. Square is also parallelogram in which all sides are equal and all angles are right angles. Understanding? Square is a parallelogram in which all sides are equal, all angles are right angles. Here I will draw and show. Just approach the diagram I will. Drawing rough diagram, okay? So 45, we are also 45, 45. Okay. It's a square A, B, C, D. I told a square is also parallelogram. It's a parallelogram in which all sides are equal and all angles are right angles. Here right angle, here also right angle, here right angle. These are all right angles. Square is also parallelogram with all equal sides and all angles as right angle. Understanding? How it is a parallelogram? What is the definition of parallelogram? Opposite sides are parallel. Here also opposite sides are parallel. Definition of parallelogram is opposite sides are parallel. Okay, here AD is parallel to BC, AD is parallel to CD. So since opposite sides are parallel, so it is also parallel. Okay, so all squares are parallelograms, but all parallelograms are not squares. Yeah, this square is a parallelogram. You draw another square, that is also parallelogram. You draw one more square, that is also parallelogram. But now I told this is parallelogram also. If this is parallelogram, whether it is square also, yes, in this case it is okay. But if I draw another one like this, it is a parallelogram, but it is not square. So all squares are parallelograms, but all parallelograms are not a square. Understood? Then what is the rectangle? Rectangle is also parallelogram. Rectangle is also parallelogram in which opposite sides are equal. Opposite sides are equal and all angles equal to 90 degrees. Or rectangle is a parallelogram with all right angles and opposite sides equal. See, you can see. I'll draw one rectangle and explain you. A, B, C, D. So it is a rectangle In rectangle, all angles are right angles. Okay, all angles are right angles. Then opposite sides are equal. Opposite sides are equal in length. It is a rectangle. Rectangle is a quadrilateral in which opposite sides are equal and all angles are right angles. Okay, this is rectangle. Is it a parallelogram? Yes, it is a parallelogram. How? Whether opposite sides are parallel or not, check. AD is parallel to CD, yes, AD and CD are parallel. AD and BC are parallel. Since opposite sides are parallel, it is a parallelogram. So how we can define? Rectangle is a parallelogram in which opposite sides are equal and all angles are right angles. It is the definition of rectangle. You understood now, students? Next, one more. Rhombus. What is the rhombus? Rhombus is also parallelogram. Rhombus is also parallelogram in which all angles are in which all sides are equal. It looks like this. I'm not constructing, I am drawing the rough diagram. Okay, construction is different. A, B, C, D. What is rhombus? Rhombus is a quadrilateral in which all sides are equal. All sides are equal in length. Then opposite angles are equal. These two angles are equal. And these two are equal. That is a rhombus. What is rhombus? Rhombus is a quadrilateral in which all sides are equal and opposite angles are equal. It is a rhombus. Is it a parallelogram? Yes. Why? Because opposite sides are parallel. Here AB is parallel to CD. Equal also, these are parallel also. AD is parallel to BC. Okay, these two are parallel also. So since opposite sides are parallel, it is a parallelogram. Okay. Then in terms of parallelogram, how can we define? A rhombus is a parallelogram in which all sides are equal and opposite angles are equal. Understanding? Rhombus is a parallelogram in which all sides are equal and opposite angles are equal. Okay? That is a rhombus. But kite is not parallelogram. Okay, you have already studied kite and also you have played with kite. So kite is also quadrilateral. It looks like this. Yeah. A, B, C, D. What is kite? Kite is a quadrilateral. This is also quadrilateral. Kite is a quadrilateral in which pair of adjacent sides are equal in length. Pair of adjacent sides. These two sides are equal in length and these two sides are equal in length. Okay, not these two. What is called? Kite is a quadrilateral in which pair of adjacent sides are equal in length. Okay. And angle A and C are not equal, whereas angle B and D are equal. B and D are equal. This is the kite. Okay. If you prepare kite like this, then only it goes upside in space. Otherwise, it goes somewhere. You should prepare like this. Understood? Understood, students? It is a site. Next one more is the that I'll tell that and I'll stop. Trapezium. Trapezium. Trapezium is also quadrilateral. Trapezium is also quadrilateral. A, B, C, D. Here, the diagram A, B, C, D is a trapezium. Okay, how one do you observe here? AB and CD are non-parallel. AB and CD are non-parallel, whereas AD and BC are parallel. So, trapezium is a quadrilateral in which a pair of opposite sides are parallel. Only one pair is parallel. Here AD is parallel to BC, whereas AB and CD are not parallel, non-parallel sides. Understanding? So, what is trapezium? Trapezium is a quadrilateral. Quadrilateral means what? Four sided close together. Trapezium is a quadrilateral in which a pair of opposite sides are parallel. One pair is parallel. So, it is trapezium. Understanding? A pair of opposite sides parallel. Any these two can be parallel or these two can be parallel. Any one pair is parallel. Then one more word is isosceles trapezium. In a triangle, isosceles triangle is there, no? What is isosceles triangle? A triangle in which two sides are equal in length is known as isosceles triangle. Here, we call isosceles trapezium if the non-parallel sides are equal in length. These are parallel. So, here AB and CD are not equal. CD is little long and AB is short. So, AB and CD are not equal. For example, if AB and CD are equal in length, if these two are equal in length, then that is known as isosceles trapezium. Isosceles trapezium. What is isosceles trapezium? The trapezium in which non-parallel sides are equal in length is known as isosceles trapezium. First point, what is trapezium? Trapezium is a quadrilateral in which a pair of opposite sides are parallel. So, AD is parallel to BC, so it is a trapezium. So, non-parallel sides, AB and CD are non-parallel sides. These are not parallel. If their lengths are equal, then that trapezium is known as isosceles trapezium. Did you understand, students?
Yes, sir.
Okay. We shall continue tomorrow. These notes are given in textbook. You can read.
Okay.
Right.
Sir, my fair sir.
Your fair I am not getting. I'll check once again. I'm checking, but I did not get it. I'll see once again.
Yes, sir.
Hello. Hello, good morning to all. Can you hear me, students? Nilesh.
Yes, sir.
Okay, thank you. Once more, good morning to all. Dear students, in the last class, we discussed about that important or different types of the forest system which are found in India, regarding the evergreen forest, deciduous forest, mixed forest, and also that structure. Today here, we are going to discuss about the distribution of the forest. In entire Karnataka, the forest variety is not equally distributed here because different regions they receive different types of that rainfall. It means different rainfalls. In some other area, Karnataka it receives very less, and in some other areas it receives a very high that rainfall. And some areas are plain, and some other areas they are mountain regions here. Because of that, different relief features, various types of relief features like the plateau, plain area, mountains, the forest is distributed variously here along the Karnataka. The recorded forest area in Karnataka state, it is 43.4 lakh square kilometer. In entire that land of Karnataka, the 43.4 lakh square kilometer area, it is covered by the forest area. And this forms 22.6% of the total geographical area. Each state and country, they should have at least 33% of that geographical area which is covered by that forest. But in the Karnataka also and then in the India also, they do not have that 33% of forest geographical area there. In the Karnataka also and then in the India also, they do not have 33%. They have less than that. Around Karnataka also, this is 23, and in India also, it is about around that 22 days. The entire Karnataka has only 22.6% of that total geographical area, which is under the forest. But it should be 33%. Therefore, it is less. Nearly 10% less is there. Karnataka has a 10% less that geographical area regarding that forest. And Karnataka is occupied 7th place in forest resource in the country. In entire all that 28 states, Karnataka it is the 7th largest state in the forest resources. Northeastern states and then Central Madhya Pradesh, these have more forest areas. And in that Kerala also, among the 28 states, Karnataka is the 7th largest state in India here, which has the forest region. In entire Karnataka, Uttara Kannada district has maximum forest area. It means North Canada. In entire Karnataka, not all 13 states here. Uttara Kannada or North Canada, it is the first in that forest region. It has the largest forest area. It is here. You can see that in the map. Then next to it are Shimoga and Chamarajanagar. First district which has more forest region, it is North Canada, and the second it is Shimoga, and third it is Chamarajanagar. Here, border of India, Karnataka and then Tamil Nadu below. I can't drag that pointer to down. Just understand, it is below that Mandya district. Chamarajanagar, it is below that Mandya district here. Below that Mandya and then Mysore there. First district it is North Canada, second it is Shimoga, and third it is Chamarajanagar. These districts have more forest area in entire Karnataka. And least it is our district, that is Vijayapura. It has less forest area if you compare with the other districts. First, North Canara, second, Shimoga, third, Chamarajanagar, and the last it is our district. Therefore, we have more responsibility to enhance the forest region or the forest area. Being as what the people of Vijayapura, it is our duty to protect the trees and forest region there. And also it is the duty of the government to encourage the people, those who will show their interest to enhance that forest area in this region. And next, here we will discuss about animal resources. To protect the animal resources, on the central government and then state government, they have formed both national parks. In that national parks, it has been they are trying to enhance their number by protecting them from that hunting, their illegal hunting in the forest region. Karnataka has a variety of animal resources, especially the variety of animal resources it is found in that Western Ghats, or which we can call that Sahyadri region, which is stretched from Karwar to that Kodagu, or up to that Navamangaluru place. In this region, and also some other area it is stretched in that Hassan, and up to that Kodagu, and in the Belgaum district also it has that Western Ghats section area. In this area, the variety of animal resources are found. There is a large quantity of different kinds of animals, leopards, birds, and spices. The main reason for this is the abundant forest land. Abundant means here plenty of the forest land, large forest area. Because of that, variety of animal resources are found in that Sahyadri region or forests of Karnataka. The Sahyadris rank among the hotspots of the world for their biodiversity. In the Sahyadri region or Western Ghats, it is the hotspot which has more than spices. It is also an area regarding that biodiversity. There are different type of that spices, animals, birds in this Sahyadri region. Because of that, it is considered by the UNESCO World Heritage Sites here, places. Every year, that UNESCO has been selecting that World Heritage Sites. Even the Sahyadri is also included in that. Why they have been announcing or selecting the World Heritage Sites here? To protect and maintain and also enhance that available sources, history, culture, and forest region of a country. How that Patadakalu, Badami, and Hampi, these are considered as the World Heritage Sites, like that in the Sahyadri region. Western Ghats region, it is also considered as the World Heritage Site and area. It has different type of that animals, birds, and other that kind of spices. Who wants to? Recently, they have been declared as a World Heritage Area or Site. Recently, it means that decade back, 10 years back, approximately here, it has been selected as the World Heritage Area there by the UNESCO. Because of that, variety of the animals, birds which are found in this region. In entire India, the left tigers are more in the Karnataka forest region there. If you compare with the other that all states here, only the Karnataka has more tigers in its forest area in the comparison with the other that states forest region and wildlife. Nearly 25% of the animal population and 10% of the tiger population in the entire country are found in Karnataka. Nearly, if you compare with the other states, entirely 25% of the animal population. It means animals are found in the region of Karnataka forest area there. And also, entirely 10%. Karnataka will be what? About of that wild animals. It has more that wild animals in it's a forest region there. Among that all that tigers is also very important. In other that state forest areas, the number of or population of the tigers is decreasing, but in Karnataka it has been enhancing here. These are the variety of that animals or different kinds of animals which are present in the Karnataka forest area. In addition to this, there are other types of wild animals too. For example, leopard, boar, which means pig, bison, stag, deer, porcupine, etc. These are the important other that wildlife animals which are present in the forest region of Karnataka. A variety of snakes and colorful birds can also be seen in the forest of Karnataka. With the different type of these animals, a variety of that snakes also are found in the region of or forest region of Karnataka. Yesterday only I heard about that flying snake in that Mysuru region. That is an example. In Karnataka it has a different type of that snake here. It is also part of that wild animal. Like tiger, variety of that different type of snakes are also found in the region of that Western Ghats of Karnataka. And different type of that birds are also found. The central part of the Western Ghats in Karnataka is called Malnad and has retained its natural biodiversity heritage. You already know there are three regions: land relief or land features, coastal region, Malnad region, and Maidana region. Here, the center part of the Western Ghats, it has considered as Malnad region, and it has here, or it has protected the variety of animals and birds which are part of the natural biodiverse heritage. In entire that forest region or that Sahyadri region here, the middle part is called as Malnad because it has hilly areas and that tall trees here and dense forest, and also in this dense forest there are natural biodiverse heritage, different kinds of birds, animals, and variety of types worms are found in the that region there. As such, this area has a rich variety of animal resource. The important forest area of Karnataka having wildlife are the important forest areas of Karnataka which have wildlife are coastal region comprising of Uttarakhand and Belgaum. It includes here North Kendra and then Belgaum district. In this region, there are more than wild animals. And Sahyadri Malnad range, Baba Budangiri, in the southern part of Karnataka, Bihar Hills, Malay Mahadeshwara Hills, and Gopal Swami Hills in the southern Maidan. These are the important areas which have more than animal resources. First region is here, coastal region, which includes here North Canada and little part of that Belgaum or western part of that Belgaum, like Kanapo district here. Kanapo district is in the eastern part of that Belgaum, sorry, western part of Belgaum. That region is covered by the different type of that or variety of that animal resources. And in the southern Maidana, this Baba Budangiri, Bihar Hills, Malay Mahadeshwara Hills, and Gopal Swami Hills, and other that hills, they have variety of that animals. The important wildlife sanctuaries are Ranebennur. You can see that in the map also, important national parks and wildlife sanctuaries here. Ranebennur is in the Haveri. Now Karnataka has 5 national parks, 4 bird sanctuaries, and 17 wildlife sanctuaries here. Karnataka it has 5 national parks and 4 bird sanctuaries and 17 wildlife sanctuaries. In this map they have mentioned here Gataprabha Pakshidama, that is bird sanctuary, and Gudivi bird sanctuary, that is in Shimoga district, and other regions regarding these are wildlife sanctuaries. They are Kudremuka, Nagarahole, Brahmagiri, Bannerugata, etc. here. Ranganapettu, Gudivi, and Gadaprabha. These are the important bird sanctuaries. Gadaprabha and Gudivi, and another one is here. I can't drag that point near there. Ranganati today. These are the important bird sanctuaries in Karnataka. And national parks, they are in Nagaravali also, and in that Kudramuka region also. In different parts of the state of Karnataka, that 17 wildlife sanctuaries are found. With this lesson is over. If you have any doubts regarding this lesson, you can ask your doubts. Hello?
No, sir.
Did you write the last lesson question answers in the page? How many of you written the last lesson question answers in the page? Raise your hand. Krishna. What about the others? 3 students raised their hands here. What about the others? Kaveri, Krishna, Nilesh, Samarth, Sampla, Shankar, Neha. Hello. Don't keep pending. Varsha, Prasya, Sufyan, Somo, Neha. Complete the phase. Don't keep pending there. If the school started, surely we will give more work there. Regarding assignment, because we have to prepare you for that board exam. Therefore, don't keep any lessons pending there. School start ಆದಂದ್ರೆ ಏನು ಮಾಡ್ತೀವಿ ಎಕ್ಸಾಮ್ ಕಂಡಕ್ಟ್ ಮಾಡಿ ಸಿಲೆಬಸ್ ಅಸೈನ್ಮೆಂಟ್ ಕೊಡು ಎಲ್ಲ ವರ್ಕ್ ಲೋಡ್ ಜಾಸ್ತಿ ಆಗ್ತದೆ. Therefore, we'll get a lot of workload if the school started. Therefore, do not keep any lessons pending there. Okay. With this year, this lesson is over. Under that 15 minutes are there. It is not suitable to start now that new lesson. I will start new lesson from tomorrow onwards. Today, with this only, I will conclude the class. Regarding the next lesson, it means water resource or any other that business studies or economics lessons to discuss tomorrow. Okay, thank you so much for all. Bye.
Sir,
What? Hello.
sir, fair cutting sir.
If you completed it, don't worry about it, Aaron.
Okay, sir.
You don't worry about it. If it is over,
Okay, sir.
then I allotted here. Okay, thank you. Then. And those who don't take your fare, come and collect your fare. They are in school. Every day, morning and evening, they are doing walking here. Come and collect your fare. Okay, thank you so much for all. Bye.
Silence है? Good morning, students.
Good morning, ma'am.
What we were discussing in previous class? Yes. Yes, students, what we were discussing in previous class? So, Rutherford's model of an atom we have discussed, right?
Yes, ma'am.
The structure of an atom. So, Rutherford's atomic model, what we have discussed in the students. So, here what we did, we passed the beam of alpha particles having positive charge to fall on a thin gold foil. So, what he did, he taken the thin gold foil and he passed the alpha particles on the thin gold foil, the beam of light. So, which he passed on the thin gold foil. We observed that most of the alpha particles passed straight through the gold foil. Passed straight means what is that? Straight. These are the straight lines. Passed through the straight through the gold foil. And some of the alpha particles straight slightly means so which they have crossed the line slightly. So they went slightly. So because of the thin coil is having more atoms. It has a more atoms and molecules. It has small particles. Okay. So and very few what happens particles appear to rebound means which they have turned like a triangle, right? So which are rebound means which they have like this. Okay. So this is the rebound. We found that by this experiment. So I will give you note of that Dalton students. Dalton's model, I will give you note of that. And next to come to that, Bohr's model of an atom. Bohr's model of an atom. Here we have already discussed that the structure of an atom. So in the structure of an atom, we have discussed that the middle part of this is the nucleus. The nucleus consists of friends. What is the nucleus consist? What is nucleus consists, students? This part is called nucleus. It consists protons and neutrons. Okay, it consists protons and neutrons. Plus positive charge, this one as protons. And there is no any charge in this. This is called as neutrons. And this part is called, we say it as nucleus. And which is surrounded by this nucleus, we call it as shell or orbit. We call it as shell or orbit. This we call it as shell or orbit. So already we have discussed in the last lesson. In the last lesson we have discussed about the structure of an atom. So here we have to find the valence number and all we discussed in the last lesson only. So this is in this lesson. So here, an atom has a partially charged nucleus at its center, and most of the mass of the atom is in the nucleus. Positive charged nucleus means here, the most of the atoms of atomic, most of the mass of the atom, where it will be present, students? It will be present in the nucleus. The second, the electrons revolve around the nucleus. Here, electrons are present here. Here we can see the neutrons and protons. The electrons revolve around the nucleus in a spatial orbit are called discrete orbits. These called as discrete orbits. We say for this discrete orbits. These orbits called we say the cells or energy levels. We say that energy levels and are represented by the letters. We represent the letters K, L, M. Then what we represent it? M. K, L, M, N. We represent the letters. These are the energy levels or cells or orbits. And also we represent the number is that K for 1, L for 2, M for 3, N for 4. K1, L2, M3, N4 numbers we represent. While revolving in the discrete orbit, the electrons do not radiate energy. They will not radiate energy while revolving in the discrete orbit. So, this is what the cells or energy levels in an atom, how they work in this. Now, in the last lesson, we have discussed about the atomic number and atomic mass and valency number, right? Here, how to distribute the electrons in different ways. You know that all the elements have a different atomic number. You know, hydrogen has one atomic number, helium has 2, lithium has 3. These are the atomic numbers. And also these atomic numbers, how they have, we have also already know about the mass of the elements also. Here, distribution of electrons in different systems, what is that, students? How we have to distribute the electrons? Because all the elements, they don't have the same atomic number. Here, you can see the chlorine has 17 atomic number, right? And magnesium has 12 atomic number. So, here the orbits and cells, they have fixed number of electrons. So, there we have to represent only fixed number of electrons. How we have to see that? The distribution of electrons in the different cells was suggested by this scientists Bohr and Bury. We say that Bohr and Bury. The following are the rules for filling electron in the different cells. How do we fill the electrons in the cell students? The maximum number of electrons in a cell is given by the formula. What is that formula? Is 2n star. Okay, it is 2n star. So, you know the first cell, K cell, what it has? It has a number, K cell has number 1. So, I use the formula to get the electrons, how many should be present in the K cell. Right? How many electrons should be present in the K cell? I have to find the electron, number of electrons by using this formula. Then 2 into 1 star is equal to what is the 2 electrons. The 2 electrons should be present in the K cell. How many electrons? 2 electrons should be present in the K cell. Then you go to the second cell, what is that? K over L. So here 2 electrons means here what is that? 8. In the second cell or orbit or energy level, how many should be present? 8 should be present in the second cell. Okay, in the L cell. And you come to the M cell, students. So M number is 3. And you put in the formula. So 3 into 3, 9. 9 into 2 is 18. In the M cell, how many? 18 should be present. How many? 18 should be present. And N cell, you come to the N, and 2 into 4. So star is equal to 4 into 4 is 16. 16 into 2 is 32. in the, what is that? N shell, how many? 32 electrons should be present in this shell. So you just count the number of electrons and put in the shell. Okay. This is what the distribution of electrons in a different shells. So the maximum number of electrons that can be filled in the outermost cell is 8. Outermost cell is 8. So you know that while finding the atomic number, students, what we have done in that time. So while finding the valency number, so what is the hydrogen is 1. Hydrogen of the helium is 2. Okay. Like that we found it. And when I go to the magnesium, students, what is the magnesium atomic number is 12. So electronic configuration is 2, 8, 2. Right? Why I can't take here 10, students? I can't take 10 here because what is the rule is there? The maximum number of electrons that can be filled in a outermost cell should be 8. That's fine. So I am taking 8 only. Okay, 2, 8, 2. If you take any number, atomic number which has more number, then
Yes.
which has 20 20 atomic numbers filled.
Calcium.
You know that calcium has 20 atomic number. I take 2 here, 8 I take. Here again I take 8 because 8 is 10. Again I take 8 here, it becomes 12. Again what is take here 12? It's 12. Right? Why? Because the outermost it becomes 8. Continuously it becomes 8, 8, 8 only. It will not come any number more than 8. Okay. So the outermost number of electrons is what is that? 8. So this is the example I am giving you, which we have already know about this. In the last lesson we have already learned. So electrons cannot be filled in a cell unless the inner cells are filled. So electrons cannot be filled in a cell, cannot be filled in a cell. If 2 electrons for first cell, what we say here, it should be only 2 electrons should be there. You should not fill here 3 or 4 electrons in the first cell. Okay. Then next, what is that? You come to that, we have already discussed that atomic number and valency number we have found it. Here, what we have to know, the number of elements given, symbols given, atomic number is given. In that, number of protons, number of neutrons, number of electrons, distribution of electrons, and valency number is there. Valency number. So here, you see that helium is having a 2 atomic number, number of protons 2, number of neutrons 2 is there, number of electrons also 2 is there in this. So protons, neutrons, electrons, how they find? We will discuss tomorrow. I will tell that how they will find it. Electrons, protons, neutrons, and electrons. Okay.
Yes, ma'am.
So you can see all the numbers it is given. What is given? We have already discussed in the last lesson. Till valency number also we have found it. Now, what is that? Atomic structure of the first 18 elements. If I say it is, what is that? Represent the electrons in the atom. Okay. For example, hydrogen is 1. So we know that how to find the electrons in the cell or orbit. Here you see cells. This is what atom structure. Here first atom it should be 2 electrons should be present. So hydrogen is having how many atomic number friends? It has only 1 atomic number. I represent only 1 electron in this. I represent only 1 electron. Helium is having how many students? Helium is having 2 electrons, 2 atomic number. That's why I represent here 2 electrons. Atomic number 2 means 2 electrons. and lithium is 3 injections. But in the first cell, how many should be present? Here, atomic number of lithium is 3 is there. It is helium, it is hydrogen. Hydrogen is 1, helium is 2, lithium is 3 is there. Then you tell me how you represent the electrons in the cell, students. In the first cell, how many electrons should be present? 8. How many electrons should be present in the first cell? Are you understanding or not, students? In the first cell, 2 electrons should be present. Okay? So 2 electrons. Lithium is 3 is there. Then what we have to discover? So we go to the next cell. So a 2 is already over, 1 is remaining. So we have to put in the next cell. Then what is the next one? 4 atomic number, which is having 4. Barium is having 4 atomic number. So here I use this first cell 2 and second cell, how many I fill it? 2 cells. Barium is 4. Then what is the next cell which is having the 5 atomic number? Boron. So boron is having 5 atomic number. The first cell, second cell I will go. Here 2, here 3 electrons I will put. So which is having 6, carbon is having 6 atomic number. So I will go to that here 2. Again I will go here. How many should be present in this? 6 electrons should be present in 8 electrons should be present in the second cell. So I can fill it 4 here. Then which is having the 7 electrons? Nitrogen. So nitrogen is having 7 atomic number. So I can represent it electrons here 2 and the second cell I can 2, 3, 4, 5 I can. Then I go to the next when 8 is, which is having 8 students.
Oxygen.
Huh?
Oxygen.
Oxygen. Okay. Oxygen is having 8 atomic number. So I'll go to that electrons first cell 2, second cell 6. Okay. So 5, 6. In the second cell till 8 we can enter the electrons. And next oxygen after fluorine. So fluorine is 9. So I'll go to that. Electrons, 2 electrons. Next is, here you can see students. How many I can enter the students? 8 I can. 2, 3, 4, 5, 6, 7, 8. 7 I can enter here. Because 2 I can enter. 7 I can enter in the second cell. Then next, what is the 10 atomic number which is having 10? Neon. Neon is having 10. So first orbit I will enter 2 electrons. Second orbit I enter 8 orbits. Okay, 8 is the last of second orbit, second cell. Then I want to go for the 11, which is having the 11 atomic number is sodium. So you can see a sodium, first cell 2, second cell 8, 6, 7, 8. And third cell minimum, how many we can enter the elements? Enter the electrons? 18 electrons. Till 18 we can write the electrons. So then, how many here over? 10 over. 11 means 1 will come the third cell. We have to continue like this, students. If you want to find all the elements, if you want to represent in the cell, so you should use the formula. Okay. Then you will get to know that the first cell how many should be there, second cell how many electrons should be there, third cell, fourth cell, fifth cell, so on. So we have more than 108 or 9 electrons. So we can find it. So there is no need to find all the elements electrons friends. Only some electrons, some elements only we use. Okay. All elements will not use friends. Only 20 to 30 elements only we use. That's why we should know at least 30 elements, valency number and atomic number and mass, atomic mass. These are things we should know. Then we have found that valency also, my students. In the last lesson, we all of you know that how to find the valency number. Yes or no?
Yes.
So valency is the combining capacity of an atom. Combining capacity means what is the combining capacity? Electronic configuration we have found, no students? Electronic configuration. So for example, magnesium 12 is the electronic configuration is what? 282 is electronic configuration, right? So it is a combining capacity of an element. So the electrons present in the outermost shell or an atom are called valence electrons, we say that. What is that? The electrons present in the outermost shell of an atom. What is the outermost shell of an atom are there? That we call it as valence electrons. So if an atom's outermost shell is completely filled, they are inert or least reactive and their combined capacity or valency it becomes 0. Okay. So of the inert elements, helium atom has 2 electrons in the outermost shell and the atoms of other elements have 8 electrons in their outermost shell. Atoms having 8 electrons in the outermost shell is having octet configuration and are stable. Here students, helium has 2 electrons. Even the first orbit is also having we can fill only 2 electrons. That's why the valency of helium is what is that students? So helium is having how many atoms? 2 atoms. So electrons present in the first orbit is 2. So here it is already filled 2 students. In the first orbit, it is already filled 2 electrons. But here the helium is also having 2 electrons. So it will be cancelled students. Okay? These to be cancelled. That's why the valency number of helium will be 0. You know that now students? Valence of helium is what?
0.
Okay, the valence of helium is 0. Why? Because it is already present 2 electrons in the first orbit. The atomic number of helium is also 2. So it is already filled. So that's why it will be cancelled. So it becomes 0. So if an outermost shell is not completely filled, it is not stable. It will try to attain stably by losing or gaining or pairing electrons with other atoms to attain octet configuration. So you know that in the first orbit 2 electrons will be present. If it is more electrons, it moves to the next orbit. Okay, the electrons move to the next orbit. So the number of electrons lost, gained, or shared by an atom to attain octet configuration is the combining capacity or valency of the element system. You know that examples of hydrogen is one lithium sodium atoms can be easily lose 1 electron and become stable. Okay. So their valency is 1/4. So hydrogen valency is what students? What is the valency number of hydrogen? 1. And the lithium is 2 is there. Okay? What is that? Lithium is 3. What is lithium students? 3. And what is sodium students? Sodium is, what is the atomic number of sodium? 11. And what is the electronic configuration? 1 is that, no? 3 is there is 2 comma 1. 11 is there is 2 into 8 comma 1. Can you see this number, students? 8. In the first orbit, 2 cells will be there. In the second orbit, 8 cells are filled, but 1 is remaining, means it is lost. So we said it's lost, we said it's lost. Okay, here you can see in the first orbit we can fill the 2 electrons, 1 will be moving to the other orbit. Okay, so helium, lithium, sodium, and which other elements also are having in the electronic configuration 1 number. Outermost orbit is 1 number, no? So easily lose 1 electron and become stable. They become stable. Okay, so their valency is also 1 student. And magnesium can easily lose 2 students. Magnesium. Why? Because what is the magnesium, this student? Magnesium is 12, right? So what is the electronic configuration? 2, 8, comma 2. Here you can see here. In the first orbit, 2 we can. In the 8 orbit, 8 we can fill. In the third orbit, 2. It can lose 2 electrons. Okay. Like that, which numbers will lose 3, 4, no? The last number is what is that? 4. So it's balance. 4 electrons they may lose. Okay, so when the outermost number becomes 5, what we do say? The minus will be 8. Yes or no?
Yes, ma'am.
So which number is that? Valence number 5 has come last. Tell me that which number is having
2, 3.
which number should come here 3, 4. Means you tell me that which is having 13 means 2, 8, 3 will come. Which number is having 15 atomic number, students? Here 2 comma 8 comma what comes here? 5.
5.
Here 5 comes. Which atomic number is having 15 here? 15 atomic number. Which element has?
Phosphorus.
Yes. Which atomic number has 15 atomic number? I'll go to here. 15, where is that, friends? 1, fluorine 9, 10, 11, 12, 13, 14, 15. Phosphorus, right? Phosphorus is having 5 here. So what we do here, if the number is equal to 5 or greater than 5 means what we do? We minus in 8. 8 minus 5 will do it. Then it becomes 3. Okay? 3. So what is the valence number of phosphorus is? 3. We say that 3. So like that we have to divide the, first we have to put the electronic configuration and we have to find the valency number of that. So you can see in the picture in the structure also, here it is first orbit, second orbit, third orbit is the same. In the first orbit, 2 should be present, 8 should be present. So 2 means it is filled 2 electrons, 8 electrons are filled here. 8 electrons are filled here. So remaining how many students? 5 electrons. 5 electrons I will make it here. So if you want to find the valency number, the 4 is the last number of valency. 5, 6, 7, 8 will not be their valency number. Last number is 4. Till 4 valency number we can get it from the atomic number. If it is more than, the outermost number is more than 5 or equal to 5, then we minus in the 8. To find the valency number, we have to do this. Understood, students? Okay? Have you understood? Say yes or no.
Yes, ma'am.
Then it is clear now, students. Do you have any doubts in this, students? Yes. Yes. You know that lose and gain is in a sense lose and gain. You know that. So your electrons 2 should be present here, 8 should be present, we say, right? So you know that oxygen, students. So oxygen atomic number is what, students?
8.
8. You know that what is the electronic configuration is 2, 6. Here, which electrons are remaining in this orbit with the oxygen gain the electrons, we say. Gain the electrons. What is that? Gain means, for example, 2 I enter here, fill the electrons, remaining 6 I gain and 2 will be extra no students in this. Because it's 8 should be present in this. 8 will be 6 in this orbit. And 2 electrons will be remaining in the oxygen gain, we say. Oxygen gain the electrons, we say. Lose means what is that? You come to that. What is the lose means? What is which number is having 10 number, students? 10 atomic number. Which element has 10 atomic number?
Neon.
Okay, you come to the neon, students. Here neon has atomic number 10 means 2, 8, 2. It lose 2. It lose 2 electrons. We say that it lose 2 electrons. Why? Because we can see here, in this we can see 8, will reach to the next orbit. Okay, we go to the next orbit. So here you can enter only till 8 and 2 will be remaining. These two, you can lose 2 electrons, we say. Gain there should be remaining electrons should be there in this. 2 and 6. In this orbit, 8 should be present. 2 will be remaining. That's why oxygen gained electrons. Neon lose the electrons, people. Neon lose the electrons, people. So, which all the elements having outermost number is 2, no? They lose the electrons. They lose the electrons. And 2, 3, 4, which number having? 1, 2, 3, 4 number which they have. Only oxygen gain the only oxygen can gain electrons. Okay, so atomic number and mass number. We have already discussed about the atomic number and mass number. Now we come to the class work, students. So till how much you are written in the class work, students? Yes, in the class work, how much you have written? Can you please tell me? How much you have written in your class work? Thomson model of an atom have you written, students?
No, ma'am.
Okay, write it. Thomson's model of an atom. So what he proposed that? Thomson proposed. Thomson is a scientist. Thomson proposed that An atom consists an atom consists of a positively charged sphere, positively charged sphere, and electrons are embedded in it. The negative and positive the negative and positive the negative and positive charges are equal in magnitude. Equal in magnitude. So the atom as a whole is electrically neutral. Have you written Rutherford's students that day? Rutherford's model? Yes, students, Rutherford have you written?
Yes, ma'am.
Okay. Then Bohr's model of an atom. All the scientists you read what is there in the textbook, students, read and keep in your mind. Whatever
Okay, ma'am. Okay, ma'am.
is an atom. What is said that by observing an atom has a positively charged nucleus Phosphorus has nucleus at the center and most of the mass and most of the mass of the atom is in the nucleus. Is in the nucleus. The electrons revolve around the nucleus in special orbits called discrete orbits. These orbits are called size or energy levels and are represented by letters K, L, M, N, etc. or numbers 1, 2, 3, 4, etc. Completed? Have you completed, students?
Yes, ma'am.
Yes.
Okay.
No, ma'am.
Erupted students. Distribution of electrons in different states. The maximum number of electrons in a shell is given by the formula. Is given by the formula. So you know that formula is the 2n square. So where n is the number of the cell, n is the number of the cell. Now you write that first cell, what is that? K is the K is number is what? 1, and you put in the formula, students. Like that you do it. K L M N, you do it. Okay. 2, 3, 4 is there, you do it. What is the answer? You do it. So what is that? The maximum number of electrons that can be filled in the outermost cell is 8. You find it students now. K means 2 and square is 35. It is 2 into 1 whole square, 2 only. And 2 into 2 whole square means it is 8. 2 into 3 whole square is equal to 18. And 2 into 4 whole square is equal to 16. 32. So these are what? Electrons. Okay, these are electrons. So write it electrons here. Okay, tomorrow I will continue the class students. Tomorrow we will discuss more about this lesson. Okay.